On this episode of Lift Arc Builds, we make a giant stainless sign. 1/4 inch, 3 layers. Wow! Hello there, welcome back to Lift Arc Studios. My name is Tay, and this episode we got an interesting, quick, but important and pretty cool build. It's a sign build. It's gonna be an oval stainless sign for a local welding school. So the Plumbers and Steamfitters Richmond and Roanoke Chapter, Local Union 10 Welding Apprenticeship School here in Roanoke Valley. So this crackled beauty is the sign that was on the top of a pole outside the welding school. But it was just a vinyl sign applied to a piece of foam board and then suspended in actually a really nicely made stainless pipe frame. I mean, you can tell it was made at a welding school.
Would you look at that?
For obvious reasons, this sign needed a refresh, and I was over that way filming a promo for them the end of last summer, probably September. It was hot still, but it was the end-ish of the year, which we've since produced and delivered to them. Link in the description. So while I was over there, they got to know me, they got to know what I did, and you know, Steve Martin is the business manager of that particular school. He's a super nice guy, and he's really all about the trades and the next generation and supporting local business. So he gave me the contract to help make a new sign. So we're gonna make a stainless steel version of this out of 1/4 inch stainless plate. That's right, folks. That right there is a 5x10 sheet of 1/4 inch stainless steel. And that is only one of 2 sheets that are required to do this project. Truth be told, I have already started. Don't worry, you didn't miss anything, and everything that I did, you're gonna see me do again. So, kind of Martha Stewarting this project a little bit.
I do a lot of gardening, but you are without a doubt the dirtiest used up hoe I have ever seen.
So here is one side of the sign that I've already cut out. It's my hand for scale, rather large hand. There's 2 pieces. There's an inner oval and an outer oval, and as you can see, it's a stainless representation, more or less, of that thing. This is only half of the sign because it's going to be 2-sided. In between this layer and the other matching layer is going to be a solid oval of stainless, which both layers will be bolted to. And the effect then will be that, see this outer red oval? Imagine that as a solid oval that both the black strip and the center oval are mounted to on either side. So there'll be 3 layers, inside, side A, and side B. Thinking we're gonna paint the center oval red, paint the outer oval black, just like this, and then leave the center unpainted and polish it up with a new tool. I finally broke down and bought the SCT surface conditioning tool from Eastwood. Been eyeing this tool ever since I got into CNC plasma. Powerful motor. It's basically marketed for people who are restoring cars and stuff that need to like strip a bunch of paint on big panels. But I am more interested in using it to apply a brushed finish, such as this, to stainless. You know, with plasma cutting, there's a lot of time spent after it comes off the cutting table, giving it a uniform finish, whether it's grinding off the dross, you know, or if it's gonna be painted, there's a certain level of finish you need to do, but especially with stainless, if it's gonna be left raw, you see everything. So being able to impart a nice linear brushed finish at the same time as removing surface imperfections like scratches and dross, that's a huge time saver. So I'm hoping this tool will allow me to accomplish those things. I've got an 80 grit Scotch-Brite pad on it right now, but what I think I'm gonna be using a lot of is this expanding drum, which is just a rubber drum that you could slide sandpaper onto. And that seems to be the quickest way to impart a nice even finish. But as of right now, I think we're gonna go ahead and load this 5x10 sheet onto the table. And once it's on the table, I will go into the drawing that I made in Fusion and the cut settings that I'm using for 1/4 inch stainless. There's a lot of money and material here, and so I've put a lot of thought and done a lot of test cuts to get this right so that the investment has been worth it. I did all this practice work in the corner of the sheet that I cut that out on just to get it dialed in. But so now I've got settings in here that I like. So I'm gonna load this sheet on and then I'll take you to my office computer and we'll look at how I designed this thing. So I recently did something fairly cool. I got an Xbox One controller to be able to control my plasma cutter. Now, how did I do that? I feel like I want to do a dedicated video on just this, but in short, I downloaded a piece of software that can take a USB connected, it's wirelessly connected, gamepad or any sort of input device, and remap the buttons to be able to do like keyboard buttons. So for instance, I mapped the arrow keys to this thumbstick. I mapped the escape key to B. I mapped the enter key to the start. I mapped Control and R to the bumpers, which is Control R is reset. And I mapped the Z axis to the right stick. You can see it moving behind me. Sometimes you need to zero your torch somewhere out there, away from the computer. And if you have a USB keyboard, a wired USB keyboard attached to your computer, that's tough because you have to just eyeball it from a distance. Well now, if I wanted to get over here, bring the torch, and zero it on a point over here, I can get it close while being right up next to it. So, super handy thing. You can pick these up used on Facebook Marketplace all the time. But I'm using a piece of software called Rewasd, or REWASD. So, but anyway, now I can go fast and then drive it with my thumb. And I can do compound movements. Again, I got my Z axis on this thumb. So, super pleased with that. So anyway, just thought I'd show you that. But now I'm gonna make sure this plate is square. We're gonna zero it up and then I'll see you on my desktop to go over the design. Okay, so let's open some Fusion and I'll show you what I got going on. Designed this part almost completely in Autodesk Fusion because I wanted to see how it all works together, but also shout out to my buddy Spike Geffert. He is a former architect, now tech ed teacher at William Byrd High School here in town. And he helped me do he's really good with CAD. I'm more of a 3D modeling kind of guy, and Spike is really good at 2D drafting, but also in 3D space. So here's the full 3D model, and this is the intended design. So we got the red center oval. That is a giant 1/4 inch oval. And then on top of that, both sides will be the outer oval and the inner oval stood off from the surface. So this is the updated logo that I cut the sign out of. And so you can see the center is white, out here is black, and then the letters here are white. So to achieve this with paint pass-through, we would need to paint underneath where this black is, we would need to paint white so that when you put the black over it, the white shines through. Down here we're good because most of it's red, and we removed a lot of this fine detail, just for ease of cutting. All that's well and good. Steve, the guy who's paying me to do all this, wants to come look at it when it's assembled in its raw stainless form. So that's fine. We can rely on his desires to dictate how we paint and finish this thing. And you can see the simplifications I made from this to this. I had to add all these connecting pieces so that the center of the letters don't fall away. And then I simplified the tools over here, the cord there, all this stuff, all the little connectors in here. And I did that in route, as a matter of fact. So speaking of in route, the reason I'm here is to open the next sheet. Yes. So here's the 5x10, and then below it is the solid oval. And so it's time to tool path it. All that being said, I'm going to take some time to tool path this in according to the 65 amp ratings. And then we'll export this to the cut computer, and then I'll export some sample parts as well to the cut computer. And we'll do some testing. When we're happy, we'll press go and we'll cut the whole thing. So here we go. Got my 65 amp consumables going in. Oops. After like 400 tries, I finally figured out why my parts weren't falling out, and I still don't exactly know how I fixed it, so stay tuned for that. But tired of wasting time to cut, so let's do it. Okay, so did a bunch of prep. So here's where we're at. Kind of got the dross off of both sides of all of these pieces. Drilled out all the holes from 1/4, which is the original cut, to 3/8 because I realized that all this 1/4 inch stainless is super heavy and I'd rather have it all held together with 3/8 hardware versus 1/4. So you saw me just using a Milwaukee brushless drill over there. Drill these out and then I countersunk them so they're nice and smooth. We're looking at the back side of everything right now because when I use the Eastwood SCT, I want to start on the back, get the back right, and then flip. And then the last thing I do is the face that we're all looking at. So we got 1, 2, 3, 4, 5 pieces. The 5th piece is over there. But yeah, now we're gonna start with this wheel on the SCT, which is an expanding rubber wheel with sanding discs. And then we'll follow up with a Scotch-Brite wheel to even everything out. Next time on Lift Arc Builds, I make a fancy mounting system for the sign and we fabricate a base. See you then.